This assessment reminds us of the nucleophilic substitution of acetylide ions with alkyl halides as a way of forming new carbon-carbon bonds. And so what's illustrated on the screen is a reaction where acetylide as a nucleophile displaces that chlorine, giving us what would be our expected, or in this case, our desired product. The assessment tells us that that was not obtained and asks us why. Well, we know that acetylides can displace alkyl halides, so it would be reasonable to expect or to hope for an SN2 reaction here. But what that does, assessment does is it ignores the rest of the molecule, right? So sometimes we get tunnel vision and we're focused only on the fact that there's an alkyl halide. But there's another functional group in the molecule, and that is a ketone. Ketones are also electrophilic and can react with strong nucleophiles like the acetylide ion. And so this is likely a reaction that happened instead. If we were to keep going with this, we would predict this to be one of the steps, one of the intermediates that would have formed either in addition to or instead of this product. We could also imagine that this chloride still gets displaced by another equivalent of acetylide. But for the purposes of the assessment, make sure you're looking at the whole molecule and considering all reactive functional groups. Alkyl halides can do substitution reactions. Ketones can do addition reactions. How could we get the reaction to how could we get this reaction to be selective to only do one? Stay tuned. I went back and looked at the problem. Apparently, you were supposed to stay tuned to this video. I thought we were going to talk about it in another one. Anyway, here we go. Well, how are we going to modify this? We're going to use a protecting group. So we need to protect the carbonyl. If we can protect the carbonyl somehow, now the only thing that will be present is the alkyl halide, and we would get the substitution. How can we protect the ketone? Stay tuned. For real this time.